Hi, my name is Joury Alamiry, and today my science project will be talking about the periodic table, its history, structure, and modification. The periodic table is an arrangement of the elements in order of their atomic numbers so that elements with similar properties fall in the same column. The periodic table has overcome drastic changes over time, and I'm here to show you what they were. But first of all, we want to know who founded the periodic table. Discovered by Russian scientist Dmitry Mendeleev in 1869 as a display of the chemical elements in order of atomic mass. The arrangement of the elements displays periodic trends of chemical elements, which I believe has a relation to how it got its name, the periodic table. He predicted the discovery of other elements too, and left spaces open for the periodic table for them. But that wasn't all, because there was a slight problem. He didn't confirm completely the order of the atomic mass because he swapped some of the elements around, which made the table look a bit confusing. But you all might be asking, isn't the periodic table by atomic number? Well, yes, but at that time Mendeleev didn't know that the atoms of each element contain a unique number of protons. So in 1913, Henry Moseley recognized the elements were organized based on nuclear charge or number of protons. The patterns fit better than if organized by atomic mass, which he used self-built equipment later on to prove the element's identity by the number of its protons, and that revealed the true basis of the periodic table. And so then he predicted confidently the existence of four new chemical elements, which were oxygen, hydrogen, carbon, and nitrogen. And this also led to the periodic law. And since the periodic law, and since 1913, the periodic table has undergone changes due to new discoveries. But before we move on, I would like to state that law. The law states that the physical and chemical properties of the elements are the periodic functions of their atomic numbers, which in a simpler way basically means that elements are described by their atomic numbers. Let's move on to modification. By time, a few undergone changes were added to the periodic table. And number one, lanthanides. These were the extra elements that belonged in period 6. They were elements 57 to 71. And actinides were also extra elements right below the lanthanides that belonged in period 7, which were elements 89 to 103. Lanthanides got its name because the first element of that row was called lanthanum, and actinides had the first element of its row called actinum. Moving on to group 18, noble gases, elements with complete valence electrons that were also added to the modern periodic table. Moving on, we have electron configuration table and its structure. The periodic table consists of 18 groups, 7 periods. And usually this will be used, and it has 4 special blocks that would be used during something called electron configuration. An electron configuration is the arrangement of electrons of an atom around a space or around the nucleus itself. Has 4 special blocks, the S block, D, F, and P. S blocks belong to group 1 and 2 of the periodic table. Group 1 representing the alkali metals. Alkali metals are special metals that are very reactive with any other element. They're lithium, sodium, potassium, rubidium, cesium, and francium. They have the same elements of a regular metal. They're good conductors of heat, shine, and have luster. They are soft and be cut with a knife. They are not as hard as iron or copper. And D blocks are most of the transition metals in the periodic table. F block belongs to lanthanides and actinides, and the P block belongs to some of the semi and non-metals. Quick summary, we have the history of the periodic table, discovered by Dmitry Mendeleev in 1869, which displayed the chemical elements in order of their atomic mass, later on changed, and modified by Henry Moseley, which organized by atomic mass, and which led to the periodic law later on. Then additional modifications over time, we have the lanthanides, actinides, and noble gases. And then later on, we have the electron configuration explanation and its structure. Thank you for listening, and I hope you found this very beneficial.